Synchronous, and even loop in JavaScript, because sometimes we're struggling with this and we don't know why, sometimes why our website feel lagging, uh, and why the process not like as expected, why the first line executed in the last, not the first. So yeah, we will talk about that. So we are going to definition of JavaScript. So basically, if we are going to describe JavaScript as general, maybe for non-dev, or yeah, it's a newbie, for example, if they asking us what is actually JavaScript, sometimes we can answer it like it's to build a website, to create a website. You can JavaScript, it's one language that supported in browser, and yeah, so many way to describe JavaScript. But if we are talk about the difference between JavaScript and the other language, or we are in this context we are talking about the process, what is actually JavaScript uh, characteristic for the as the language. So JavaScript is the first one is using single thread, just single thread, and then it's a non-blocking, non-blocking. Sorry if my handwriting is bad. And it's asynchronous, asynchronous, and the last one it's a concurrent. Uh, so yeah, the first one is single thread. It's sim like weird how single thread language can do asynchronous. So that's why I will explain JavaScript first, so we able to understand the why. So single threads means, yeah, I think all of us already know it's like executing the task with one thread, just one thread. Like for example, we have ice cream, how to say, seller. Maybe we have, for example, yeah, this is the seller, and say and we have buyer here, buyer one, buyer two. It's we need to serve the first buyer first, make it done first. For example, in this case, it's blocking process, but we just have one seller here, or let's say it's a ice cream maker. So yeah, we need to serve this buyer first, and then the second one, that's the third. So yeah, need to handle one by one. One, two, three. uh, Wait. Oh, but this means the blocking process. And how about multi-thread? Multi-thread means we able to have this like restaurant. For example, we have restaurant here. We have more table. Let's say this the chair, and we have so many chef here. Like for example, three chef that will serve our the menu, the order, and yeah, we able to serve these three table at the same time because we have three chef here, or three. So it will be like this. We able to, if it's asynchronous, we able to make it parallel like this, or if it's still we don't want to make it asynchronous, it's still using this, but it's with different save, for example. Yeah, depend on when the order coming. So that is the thread, and JavaScript is using single thread. Okay, and now we are going to the non-blocking. We know it's a task. If blocking, it will be like this. This task one, this task two. We start this, we start this, and we need to make this done first before we can go to the second task. It's be waiting. But if we have non-blocking, it will be like this. Let's say we have two tasks here. So we start this. Okay, we start it, and whatever, when it's done, we just start it. If it's not possible to direct to done, okay, we go to the next task, and it will be possible to the second task previously will done first. It's possible, and then for the second first task at the last. So yeah, this is non-blocking. So we just start the process, and we don't know when it's done. What the order. That is the non-blocking. And asynchronous, it's similar like that, but if we are talking with asynchronous, it's related with the non-blocking, but non-blocking, it's focused to I/O, input output. Asynchronous, yeah, identical with HTTP process. And yeah, it's like we fetch two website and then two API, and we need to wait. Uh, we need to wait, or we cannot now where who or which the API will done first. Yeah, of course, it will be blocking, or as if we asynchronous is not non-blocking. And concurrent, because we combine this concept to single thread. So the concept will be like this. This will be this called concurrent. Correct me if I'm wrong. But if we are parallel, okay, single thread, we have multi-thread. Non-blocking, we have blocking. Asynchronous, we have synchronous. But concurrent, we have parallel for comparing. Parallel will for example, we have two threads here. Parallel will be execute the task like this. This the first and the second one. It will be in the same time. Okay. For example, this the first second. This will be per second, and then 2 second, 3 second, 4 second. So this will be caused in the uh, resource, because let's say we have to save. Of course, we pay to save for doing the job. But if we are using single thread, it's just we pay one save, but it will be the cost. It will be the time, because it's still executing one by one. But yeah, this is the JavaScript. It's still executing things one by one, but we able to start it without waiting it until done to start another process. And yeah, it will be like, wait, right? How JavaScript can do this? Because yeah, what's the indicator this is done after we started? So let's talk about the engine of JavaScript. So we have V8 as engine to run the JavaScript. We call it V8 to run JavaScript. And we need to understand two things in V8 engine. We have this the important things is we have heap and we have stack. So heap it's using for memory allocation. So in case we declare a variable, a function, it will be stored, all of that will be stored in heap allocation. And stack, it's for function call and execution process or context. So let's say we have example here. I'm sorry. We have, for example, console log 1, and then 2 and 3. It's just simple code, right? And because JavaScript have just one thread, it will be like this. It's read this code, executing. Okay, we have log. It's function call because log it's already a function, right? Okay, we are going to put it to the stack. Log one. Let's say this is the console preview. And after we register it to stack, we will executing it directly. If it's done, it will be removed from the stack. So let's say this ready print as one. Then we move to the second task. It's now log two. Okay, print it to the console. It will be two now. And then remove it to the stack from the stack. And the next, we move the cursor to 3 now, log 3. So now we have 1, 2, 3 in the console, and then remove this. And all of the process already done. And how about if we make it more complex? So for example, here is we have nested function that call from other function. For example, we have function A here. It will like just return string, for example, hello. And then we have function B that call function A. And then we have function C that call function B. The last one if uh, I mean we call the function C. So yeah, let's or anyone want to try describe it how it's going to stack heap or anything. Anyone wanted to try?
Let me try, but if
Okay,
wrong,
no problem.
okay,
We can
let
go.
me try.
YOLO, just YOLO.
Yes. Okay, so the first we call the C and we put it
Okay,
into,
so you are going here first, right?
yeah, we the C, it will be put to the stack.
Okay, let's say here
Then
is
since the C is not done yet, we call B and we put inside the stack,
okay.
and the B is not done yet, so we put a function. Is it A? Oh yeah.
Yeah, yeah, yeah. Hey, okay,
And then after call the A, it will be print hello.
okay. Let's say it's console log. Okay,
Yeah.
now it's hello.
And then the A it's already done, so we remove it from the stack.
Okay,
And then B also done, so we remove B from the stack.
okay,
And C is done, so we remove from the stack. Yeah, hopefully
okay.
it's
That's
correct.
cool. Yeah, yeah, that's good. But we miss about the heap.
Ah,
Because of course we are not start from here, right? The process will be start from here for the first line. This will be okay. We made A now. We put in the A to the heap as a memory allocation, and then we have JavaScript or engine. We will skip the content of the function. Okay, so we are moving to this function declaration. We put it to heap. Okay, and then now we move to C. I still not call it just decoration, so we just put it in the heap, and the last one we call it. So we call C from the heap, right? So yeah, C now call B. Like yeah, like what's your explanation before? Call B. This will be go to C and then check the inside. Okay, B. Now register it to stack, and then we are going to B. Now check the content. This will be A now. Okay, and the A, for example, let's say this log, so it will be just log hello. Okay, and then execute this. Okay, and then print hello now. Now remove it, and then A done too. B, call A, it's done, so B it's done too, and the last one C it's done too. So yeah, that is the process behind of the scene from JavaScript V8
Uh,
engine.
when does it get removed from the heap?
When you restart, for example, the engine.
I see.
So let's say we refresh the browser.
Yeah.
Uh,
but
oh yeah, so that
I'm not sure if but yeah, if I have like tab open in the tab, and then we just go to task manager of our browser, we can see there how many memory allocation on there, right? And also, if we are going to the inspect tool, we able to see performance monitor there. We have JS heap there. You can see how many variable that store in your memory. If I'm in laptop, I will show, but maybe later. Uh, yeah, if we restart or kill the process, it should be removed from memory, of course. And yeah, and let's move because this is the okay the simple code. There is no asynchronous process now. So yeah, let's go. How about if we meet asynchronous process? I'm not directly talk about fetching. Let's say we are have log here, console log one again, and then now we have set timeout. Set timeout. Let's say in the side of this, we have log two, then we executing it for 3 seconds. After 3 seconds, and then the last one we have log three. So yeah, what's happened? Anyone want to try again? This will be more interesting. Anyone? Brave? Okay. No? Okay. Let me demonstrate that. The first one, it will be log one. So let's say here is the console. Uh, okay, we print it. So it's one now. Now we call set timeout. Set timeout is a function, right? If we are see the, it's not declaration. So okay, before it we remove this. We move to here. So it will be set timeout here. But now we need to waiting it for 3 seconds. How about that? So yeah, this not done. If JavaScript is non-blocking, I mean blocking language, it will be waiting this and then process the log tree after that. We need to waiting it and then uh, we can execute the log tree. But in the fact, the result is 132. So yeah, I will explain why. Let's remove this first. I need to have more space. So yeah, I will move this. So the in JavaScript we already have V8 engine, right? But we are running JavaScript in browser or Node.js. And if you know Asynchronous or Node.js, for example, will help us to handle the asynchronous. So we have Web API here. We get more thing to handle this code. So it's called Web API. It's will coming from the environment. For example, if we are running the code from a browser platform, it will be the browser will have web API, some web API they provide, or we can call it browser API too. For example, we have document here, document get element by ID, right? This this uh this is a synchronous process too, because we need to find and wait the DOM. Of course, we wait the DOM until it's done to load, and then we find the ID. If it's not, there is no the ID from there. Okay, we can reject the process. So yeah, here is set timer to interval, and the fact is console log is not part from JavaScript. It's coming from web API. Console log. Console log, it's from browser directly or Node.js. So maybe sometime, for example, Chrome launch a new feature, like for example, console.table. We have table now, but let's say it's a new feature. We able to show the log as table. We have a new feature console.table, but it's still not supported in other browser because just Chrome provide that web API, and JavaScript. It's the maintainer currently is TC39. It's have a promise. There is no deprecated code in JavaScript. If we are going to read the JavaScript history, there is no JavaScript code uh, deprecate, even its bug. If we are going to check, for example, type of null, this is bug in JavaScript because it will return object. And null is actually a primitive data type in JavaScript. So of course, this will be actually should be null too, because this is data type in JavaScript. But yeah, it's return object, and we cannot uh, fix it because JavaScript is a backward support. What you write in the past will never deprecate. What deprecate is always just coming from web API. So if we are using, for example, document get element ID, and in the future it will be removed, your web that previously using it will be broke. So yeah, we need to be careful to using web API. If it's like uh, will deprecate it, sometimes it's will have alert from the browser. We need to avoid that because this will be will broke our website in the future. But if JavaScript it's native from JavaScript, there is no problem. Even we access web from first website in the world, it's still able to run perfectly. And then, okay, let's go to continue this web API. Okay, we can remove it first, and we have fallback queue. Fallback queue. So this tag will be focused to asynchronous fallback or process. And then we have even loop. We'll draw it like this. Even loop. So yeah, I will explain it later. Even loop. This is so important in JavaScript because sometimes we meet uh, this problem. Our return or expectation is it's not correct because let's move to here again. For example, okay, let's go to log first. Log one, it will be go to the stack. Okay, like like previously, and then it will be print to the console. Okay, let's say it's already print and we remove from the stack. Now we are going to the second line, the set time mode. Set time mode is part from verify. So we put here first and we check it. Okay, it's part of web API and it's a synchronous process. So yeah, we put from here to here the timeout. And the callback will put here until 3 seconds. So we'll be waiting. So we continue to here because it already done to process. I mean done to put to the web API queue. So we move to log 3. Now print in the console and then remove it from the stack. Now we have set timeout left. It's for example already 3 seconds, and we give the callback. Inside here we have console log 2, so it will be go to here log 2, and the term to move log 2 to the stack to execute, it's we need to make sure the stack is empty. So if we have still have tasks here, for example, we have log 3 here, this will be cannot uh, to execute because we need to empty the stack first if we want to processing the callback here. So in this case, it's already empty. Now even loop can be processed. It's just move from callback queue to log to stack. So now log to here, executing it. So print it to the console, and then it's done. So that's here is done too. Here is too. Oops. So yeah, that is the process of event loop. I think that's all enough for now. Maybe you can focus to discuss. Thank you.